Welcome to the Newfangled Workshop podcast. Before we get into it, let's hear a little disclaimer.
The views expressed here are those of the participants and do not reflect the views of the United States Military Academy, the United States Army, or the Department of Defense.
Welcome to the Newfangled Workshop. This is episode number 5. I'll be hosting this evening. I'm Matt in Minnesota. Let me introduce you to my brothers. This is...
I thought you were going to introduce us.
No, I was waiting for which one of you would jump in.
No, you said you're going to introduce me, so you got to do it now.
Oh, so I'm Matt from Minnesota. This is my brother Steven from Chantilly, Virginia.
Hello.
And this is my brother Ledley. We call him Led from Cornwall on the Hudson in New York.
Good evening, everyone.
Excellent. So I think we're getting the routine down. This is where, as I said, this is episode number 5. So we have 4 in the books and up and published. This is pretty good. We've gotten some number of views, right? Somewhere between 1 and 1 million, right?
So some number meaning some number between 0 and 10.
When we used to run the radio show, we used to say that we were somewhere between 1 and 2 million.
Okay, I can accept that.
So we're somewhere between 1 and 2 million.
So I've not yet gone viral.
Correct. And I don't think that we intend to. This is for our own enjoyment. And if anybody else gets some benefit from it, that would be great. I think tonight's episode has the chance to actually be fairly instructive. I think that we have some content. This is something that I think some of us are familiar with. And then the others can ask intelligent questions as we go. But I wanted to focus, much like the lighting episode, that was episode number 2. Tonight's episode is going to focus on something called CNC. And this has a lot of different meanings, so I thought I'd start off with the very basic: computer numerically controlled, right? I think is the right explanation of it. And what it typically involves is some level of gantry operation that will allow you to manipulate a head that's doing some operation. And so many of the tools that you'll find in the crafting space and in the industrial space are actually CNC machines. So things like your Cricut is a CNC machine that works a little differently. Your 3D printer is most likely a CNC machine. Your woodworking router version, and then your metalworking end mill kind of CNC that can be a very serious piece of equipment. And so lots of things within CNC. Tonight, I wanted to focus on what is my aspirations of woodworking CNC. And so I want to talk about the middle of the road somewhere. I want to run a spindle or a router on the end of the CNC and talk about what that operation is like and some of the features and stuff. So let me start by asking you each, what's your background with CNC? How much exposure do you have? Could you give me a little personal narrative? We'll start with Led. Led, could you give us a little bit of background? How much CNC experience and exposure have you had?
So I'd put myself mostly on the user end of CNCs rather than like an operator or someone who knows all about the metallurgy of the bits or stuff like that. I love CNC capabilities in that you can draw stuff, whether it's SolidWorks or even SketchUp or AutoCAD, whatever it is you're messing around in, and then you can drop it into one of these programs and you can cut it out of foam, or you can cut it, or you can have it printed out of plastic, or you could have, some giant 6-axis machine cutting a piece of limestone into a column. And I've definitely used I've used water jets, right? So water jets are a type of computer controlled machine that really only have a couple axes, and then they shoot the water out of the super high jet, high power pressure jet with like some garnet and stuff in there. They make a pretty good amount of mess, but if you're cutting 1/4-inch steel plate into a bunch of fancy shapes, say you were doing gusset plates for a big timber truss you're putting up in Harriman State Park, then you needed 70 of these plates, out of 1/4-inch steel, and it's a 1 foot by 1 foot plate. I've also seen a fair amount of wood cut with water jets. I know people don't think of water jet as being appropriate for wood, but I've had a lot of good success with it. You just got to make sure you dry it out afterwards. So, but again, I'm mostly drawing parts and then dropping them to an expert who then operates that CNC. That's my principal CNC experience.
Excellent. So, Stephen, what's up in Northern Virginia?
Oh, send, cut, send, right? So, if you're a hobbyist or someone like Led describes who has some artwork and needs to send it to a shop and get it back, that's one of the most popular options right now is a service called, and I don't know what the URL, but you could Google it, send, cut, send. And what happens is you send them your digital artwork and they return, the cut part, the printed part, the water jet or the CNC milled part. Um, it's a premium versus like running your own, but running your own requires space and time and learning, right?
Mhm.
Yes.
My experience, so I'm a hobbyist, I guess is the best way to put it. And then I belong to a makerspace in Fairfax, Virginia. And the makerspace has a number of CNC machines. And I sort of enjoy working with them, fixing the broken ones and, like that. That's like the Island of Misfit Toys and fixing stuff is kind of what I get kind of attracted to. I don't know why. But that's at our shop, we have a bunch of CNCs, and I'm one of the two fellows who maintain them and help instruct folks on how to use them.
God bless you for your service, Stephen.
Yeah,
Like, because
exactly.
I'm the guy that would never try to mess with the machine. If I want to know how the machine works so I can draw a part that can be made.
Yep.
And I can know what types of materials, especially different types of mills can cut. But trying to get those things to run right is tricky business. So here's hats off to you for doing that.
So there's
But
two things.
I could give you a list of CNC machines that we have in the shop, and it's long, right? Because we have a long arm quilter, which is 12 feet wide, and it can do quilting with CNC. We have a 12 thread embroidery machine that runs on CNC, and then some tabletop embroidery stuff. We've got the cry cuts, the silhouettes, the US General vinyl cutters, right? We have 3D printing, resin printing, CO2 lasers, right? Because CO2 lasers are CNC as well, right? A battery of printers, right? We have the 42-inch roll printer and an 8-foot roll printer that we have in the shop. And then we have a wood CNC, which is a 4x4 wood CNC with a 3 horsepower motor on it, right? A spindle. And then we're getting a new one. We're getting the 4x8 multicam CNC with a vacuum hold down table, which is nice.
Is that for
Uh,
wood or foam or what's that one for?
well, pretty much anything but ferrous metal. We'll cut thin aluminum, foam, wood, acrylic, epoxy.
Think
If you have
think
make
any
your river table,
So Led,
sort
think anything you could cut with a router, except the router is strapped onto this thing that drives it around.
basically, yeah, basically,
Yeah, so it's a gantry router.
Yeah.
yeah. And what else we have? We have a Maslow router. We have what we call we have a Sane Smart 3018 router, which is 30 millimeters by 30 centimeters by 18 centimeters. We just got a new General CNC, which is 15 inches by 20 inches. We have a Maslow metal mill, and we have a Haas VF0, and we have a CNC Junior metal mill too. So we got quite a collection,
So to be
right?
clear, Led, when I thought about doing this as my topic for this evening's show, I called up Steven and was like, "Hey, would it be okay if we leaned on you heavily for tonight's episode?" So I know I'm supposed to be hosting. I expect, like yourself, to be learning a great deal. Steven just rattled off 15 machines, right, that he's using in the shop down there, and I learned something from all of it. I want to back up, Led. I had the opportunity to visit a state-run makerspace that was very decked out. It was supported a very large engineering school,
Huh?
and they had a water jet that operated at 55,000 psi. And they informed me that they can successfully cut through 5-inch steel.
We
Right. So
we've done up to a couple inches. Um, and we've done marble a little bit thicker than that. So
it's
but
kind of impressive.
I don't, yeah, but I do wonder why, like an engineering department at some state university would be wanting 5-inch thick steel plate. I mean, that might be time to call in the inspector general and see like what the heck exactly they're up to. I mean, what are they building?
So they're
Well,
building some pretty neat stuff. I was very so I thought that was very very slick. And then Stephen, on the list of machines you talked about very initially, do you have any crickets in the space?
oh, we don't have that brand. We have the another brand, the Silhouette, I believe.
Okay, but it does the
Uh,
same kind of thing. It's just an X-Acto knife stuck on a
well, it's a
CNC machine.
tool. You can put a number of different tools in that tool holder. You can put a pen. You can put some other stuff in there too. So it's just a
Oh,
tool
wait,
holder.
is it like one of those old pen plotters from back in the 80s that will like do an XY plot with and it'll pick up different pens to
Yes.
draw? Those things were
Some of them are
nuts.
like that, yeah. But the most of them are vinyl cutters. They have a real sharp X-Acto knife in them, and they'll cut vinyl, right?
So
We also, I forgot, we have a plasma table, a 4 foot by 8 foot plasma table, which would cut up to an inch of steel, right?
And that's
So
using like electric. That's like you. I mean, how does the plasma? How does it make plasma? Is it like using
like,
electricity and shooting some kind of wire? Or...
well, so do you know plasma cutter, a handheld plasma cutter? Like you can get
Yes and
one.
no. Like, what do they shoot? I mean, are they shooting some material to make it into the plasma, or like?
It's arcing. No, it's just an arc.
Oh, it's
It's
just an arc. Okay.
it's an arc based, and they blow air on it, compressed air, pretty high rate. But
Okay.
you can
So
get a
it's the air.
handheld
It's the
one.
air that you see going everywhere when they're doing it.
Yeah, spark. Well, the air is blowing. The plasma is doing the cutting. The air is blowing the molten metal and the sparks, the particles, away from the work surface. Yeah,
so that was on my list of topics for tonight is to talk about safety. If you're going to fire molten metal at me with your plasma cutter, I might want to put my welding shield on at that point, right? Like I may not just want to have my safety goggles on. I might want to protect my entire face,
that's right. That's
kind of
right.
thing.
And plasma, you could get away with a little lighter shade, like shade 8 or 7. You don't have to go up to 13 or whatever for welding.
Yep. Yep.
But
And this is also where they talk about a lot of the guys who work in that space will wear their hats backwards. And I just thought they were trying to be cool. And it turns out when you have the bill in the front, right, like you can't put the mask over it, or if you're doing other milling operations with the cap on with the bill in the front, pieces will deflect off of the cap into your face and into your eyes. Like the baseball cap is actually a danger tool, not a safety tool, which I thought was interesting. So,
some of them wear the do rags, right? Often they'll have like a non-synthetic, cap of some sort.
yes, 100%. So I want to talk about, you mentioned briefly you had the Maslow machine, and I thought that would be interesting to talk about. I broke down categories for the types of machines. And the very first one, there's a company called Shaper Origin that makes the very slick product that is a handheld router that has image stabilization for the bit. So as you drive around with your hands, it will keep the path. If your hands wiggle a little bit, it'll keep the bit on track and not get that vibration or the movement. You can be off by as much as a quarter of an inch anyway, and it'll keep the bit in the path. And if you go out of the tool path, it raises the bit up so you don't ruin your piece. And so the Shaper Origin is like a handheld version that's very, very interesting. It uses this a camera on the front, and you put down this weird domino tape, right? And it knows where it is on the piece of wood based on seeing the domino tape that you've laid out on the piece of material.
So you've been demoted. You're actually just the gantry.
Correct. Yeah, right. And but it uses that like
Humans are serving the machine.
no, AI is coming, right? We get a whole different
No, it's
episode.
not coming. It's here, and it has taken over your router table.
Um,
You are not the router. It is the router. You are just the holder of the router.
So the thing that's cool about the Shaper Origin to me is that you can take the tool to the work. In a lot of these scenarios, you're bringing the work to the tool. With the Shaper Origin, if you want to do a fancy inlay in somebody's hardwood floor in the middle of their dining room, you can do that because you're using a handheld router. You just put the tape down on the floor and it sees that as the material it's going to cut through, which is really slick. There's another version in this same category called the Goliath. And the Goliath has these towers at the four corners that you're going to operate in, and it has cables that drag the router around on your surface. And so you basically set up like a gating system and you say, here's the boundaries that you can play in. You put the cables up to it and it drives around on wheels So you're not even doing the handheld. At this point, it's driving the wheels and pulling with the cables to make sure that it all stays in bounds. And so Goliath is another interesting in that handheld, bring the router to the work scenario. It's a very slick option. Next up is to me, you can get some very small form factor, like a 12 by 12 bed kind of thing. You run down to Rockler, you can run down to Woodcraft, and get a fairly interesting CNC operation from them. But these are very hobbyist level, I think. Then there's the build your own, right? Or the roll your own kind of operation where you are, I'm thinking Shapeoko, I'm thinking of the X Carve. These are,
No, can I interrupt?
yeah, please.
You're on a roll.
Please.
It's the MP, like Michael Paul CNC,
The mostly printed.
the mostly printed CNC. If you want to roll your own, you go mostly printed.
Yeah, so the mostly printed is you go over to your 3D printer, which is a CNC, and you print off these corner hubs and these other pieces, and then you run down to the store and you buy a bunch of tubing, right? So you run down to your Menards or your Home Depot or Lowe's or whatever, and you buy a bunch of steel tubing, and then you mount them inside these pieces that you've printed. And the thing that's cool about that operation is you can make it whatever size you want, right? If you want to make an 8x8 machine, go for it, right? Because all you got to do is more tubing.
And then what does it do?
It's you build the gantry yourself. So you're building the
Ah,
XY gantry and you're printing the wheels. They're gonna run around on the steel. So they run on like V wheels. And so they have these V wheels that sit on top of the tubing.
so you're not content to use the machine. You must make a machine.
Right. So that's the MP
And
at
you're using a
CNC.
3D printer, using a machine to make the machine with which you are going to make things
You're getting the idea.
With AI, yeah.
with AI.
Steven's going to show us an example for those tuning in on the YouTube stream. This is what they look like, Led.
Yeah, so this
That
is
looks too pro. That looks like a
MP
pro built
CNC.
that. That's not a
Yeah,
hobby guy.
this looks more like a hobby guy here. Is this better?
Uh,
Got a little Dremel on there, trim router.
Yeah, and there's a lot to be seen in this
Oh, good.
picture. But the idea is that you build the gantry yourself, Led. So you're not buying the engineered, highly, configured stuff. You're building it yourself to your own level of tolerance.
And
Hmm.
the trade-off there is, if you buy tubing from Home Depot, it's not a linear rail, right? Or it's not a helical scan, horizontal drive system, right? It's good to about, what, 1/100 of an inch over 8 feet or whatever. So you're, the other thing that Matt hasn't really mentioned yet is the rigidity of the rig, right? And so
Big problem
all
with
these,
robot arms.
yeah, as we go through the sort of the categories and classes of machines, how well the machine can hold a point, right? And if it's going from 0.00 to 0.11, how well can it hold on to that under power? It has to do with how rigid the gantry is or the arm, the robot arm or what have you. And it's a big deal, right? So
Well,
your
how good the
lower end
cameras are
machines,
too.
what?
No cameras.
Huh?
Well, I mean, you got to some of the machines see, right?
A small portion, yeah.
So that's a very fancy, like the Shaper Origin that I was talking about uses a camera. In these gantry systems, it just knows the XYZ itself, right? So it's working inside its own playground, and you're sending it G
Right. They
code.
got some sort of screw inside of them that tells it where it's at.
Well, and so now we get into the stepper motors, and I'm learning a lot about this week. So we have
Servos and
stepper
steppers.
motors, and you have to say NEMA 23, right? Like if you want to be a cool person, you have to say NEMA 23.
Small one.
Yeah, those are the little guy ones. And then if you want to be fancy, you step up to the bigger NEMA machines. But these are stepper motors that will turn a screw a certain amount. And the kinds of screws, there's this problem called
Stepper motors I know well. Stepper motors and the stepper motor controllers are a big deal.
they
Yeah.
Like
are.
exactly which stepper motor controller you're going to buy.
And then there's also what are you going to attach to your stepper motor? And there's this
Stepper
problem with something
controller.
called backlash. Stephen, could you talk about backlash a little bit?
Yeah, backlash is, I don't know if you've ever turned something that runs on a screw, right? And then you're turning the handle one way and you've moved it all the way right, and then you're gonna move it left. Well, sometimes you have to turn it a little bit before it starts moving back left again, right? And that's the backlash, is how much slop is there between going forward and going backwards when you turn the screw. And depending on the quality of the machine and the type of screws that you have. It can be very, very tight tolerance or very large tolerance.
Well, it'd be how fast you're trying to go too, right?
Yeah, so
Like
so speeds are a thing.
It's a factor, yeah.
yeah, because
Like
you're going to
with
store
lathe,
you're going to store momentum and you're going to store elastic energy inside the screw as you're turning it.
true, yes, true.
So this is
Lathe
the
operators
physics
can talk
calculus
about
guy.
their lead screw all day long, and the lathe operators are just super knowledgeable about that. Yeah.
Yeah. Yeah. So and then yes, the mostly printed CNC, and then you get into the build your own. They send you a kit and it comes with all the rails, it comes with the fancy engineering and all the parts and all the and then
This is when you want your part like 4 months from now. Like
uh
I'm going to get a part 4 months from now because I'm going to spend the first 3 months making the machine that's going to make the part.
correct. That's 100% true. But then once you've got your machine up and running, then you're supporting your operation and they show up and I need a screw that looks like this. Okay, give me 30 minutes and you'll have it. Right? You don't have to go to the hardware store
Okay.
because you've got your oh, I don't think with you have your slabs that then you can make your part out of. So it is building an operation. It's like saying I want to start building cars. Well, you got to build a factory before you can build a car, right?
Right,
Well,
but
so
my point is that you don't really want to be building such a machine to make one part,
No.
right? And that a lot of times, for hobbyists especially, farming it out is actually going to be cheaper because so
Oh,
hopefully you're doing it out of the joy of the making of the
yes.
machine, not because you believe you're going to save money by doing a homebrew machine instead of sending it to some pro who's going to knock out the part for you.
Okay, so I'm going to steal Steven's material now. When I wanted to get 3D printers 3 years ago, and I put them in the makerspace, and I said, let's start printing things. One of the lessons I had to learn from Steven is don't print anything that you can buy at the store for $1. Right? If you can go down to Dollar General or whatever it is, or your dollar store and buy it for $1, why would you ever want to spend time printing it? That right? Don't get into the production business of things. I don't want to compete with the guys who are making 100,000 of a thing. I'm trying to do a custom piece of work. I want somebody's name buried in something. I want it to be a club picture that's getting buried in something, right? I want to do the custom work, not the production work,
yeah,
right? And
bespoke.
that's
Everything's bespoke now.
right, handcrafted here. And that's something I've been thinking about. This is a much larger conversation. I've been thinking about that with some of my woodworking is that I tend to go with can I build this thing? And to me, it's a very binary, like I figure out how to build it and I build one. I need to get into more of the process of build a second one and a third one better. Right now that I've mastered the process, now let me actually build something that's a fine piece of furniture instead of like, hey, I built this and I figured out how to use dados, or I built this and I did a bent lamination. My bent lamination wasn't very good the first time. If I did it again or a third time, I'd get better at it. Right. So there's a much better like iterative process. So
But,
One
but
of
do you
the
really want to be a furniture factory or do you just want to be like a guy who makes some furniture? Right? That's the philosophical question here.
it is. And
but
Steven's got an interesting take on it.
one of the things was when we get into the machining and everybody talking about it, when you have big construction projects, like Led knows about big construction projects,
Sure.
one of the first things that is typically built is the machine shop, right? And in the machine shop, you put a lathe and you put a mill, right? And then if some of your gear breaks or you need a special part built on site, you walk down to the machine shop and you hand them the stock and they, some smart machinist dude is there to turn out your part for you. And so this is very traditional in more our parents' generation when they were building a lot of construction and stuff. Oh yeah, there's a
They'd have
shop going
sawmills
in.
on some of those places.
Yeah.
Right. But now, I mean, nobody's got a sawmill on their site. Everyone's bringing in dimensional lumber. And I would say that's largely in the construction business. That's what happened. The amount of fabrication that they're doing on site versus assembly is very tiny.
Mm-hmm.
Right.
Mm-hmm.
They're doing assembly, not fabrication, by and
Well,
large.
I've seen operations where they're actually moving the assembly into the factory part and then shipping you out flying slabs of whole walls to then just do
Sure.
Legos. right, and assemble it. So where do you actually even do the assembly? If I can do the assembly inside, that makes a big deal, right?
Yeah, and probably some of the biggest CNCs in existence right now, they've been working with printing concrete houses.
Yes.
You've probably seen these, they set up this giant CNC machine that's basically a two-axis machine or three-axis, because I guess you print a layer and then you jack it up, and then you print a layer and then you jack it up and then you print a layer. But they're really cool to watch work, and I think they're getting better at it all the time. The thing that we've been having the most trouble defeating, of course, is the reinforcing steel that needs to go into concrete to, because concrete won't carry any tension. So you put all the steel inside it. And so far, most of that's being hand tied, or all of it's being hand tied.
Huh.
I know on the smaller scale in the 3D printing world, being able to put a strand of wire between the filament that's being printed to do the bending and to do is one of the dreams, right? The dream is to be able to 3D print around a piece of reinforcing metal. Which is an interesting space. So back to the CNC stuff. The next class is the build it yourself. They send you a kit. It has all of the parts. You spend a couple of weekends doing your Lego set of assembly. You break out your wrenches. You break out your screwdrivers, your Shapokos, your X carves, right? These kinds of things show up as kits. And then there seems to be a whole nother layer where you start getting into the semi-professional, much beefier motors, much beefier rails. And then there's the true professional guys. These are the big ones that Stephen was talking about at the front end, the 4x8 sheets, the vacuum presses. There's even like automatic sheet good feeders that you have your 4x8 CNC machine, and then you've got a pile of plywood on the end that automatically moves the next piece in. And so the human is standing there just making sure there's enough plywood in the feeder on the front end, and then taking pieces off the back end as it comes off the other side. And that's a very expensive operation. So at the hobbyist level, you can probably get a CNC to do some 3D printing for you, sub $200 to $150. At the very high end, the very fancy bougie plywood sheets that I'm used to, you can easily spend 80 grand, right, to get an operation up and running. They're very, very fancy. I'm thinking of things like Laguna at this point that are just stunning to
Well,
me.
you can spend a lot more than
Yeah.
that.
So so the cabinet shop guys that I've been around to see, it's pretty impressive.
I think we just spent 950 grand on a machine that does 3D printing.
3D printing stuff.
Yeah.
Yeah.
Yeah, it does bed-based, it's actually using lasers or some sort of plasma thing to make these metal beds into layers. It's pretty awesome.
So I think I've used up a significant amount of my time, but I do have a couple of things that are worth talking about to be educational to some people listening. I was fascinated to learn about the difference between the 2D printing, the 2.5D printing, and the 3D printing. And this is how much X-axis and how do you handle the the Z-axis. So 2D printing, you're just dragging the laser around. This is like the chain-driven Maslow's, right? That they're not moving the Z in the middle of the operation.
Maslow can just to.
With the chain drives on the panel saw setup?
Yeah, it's got a linear rail, C-beam linear rail typically, or something similar to move the router up and down. So,
Interesting.
on the router sled. But anyhow.
Yeah, so if you see, for example, the classic project to do is the wavy American flag, right? So you want to do the wavy American flag where you've got the nice little wind ripple effect on the flag. And the challenge is that you have to manipulate all three axes at the exact same time as you're doing that, right? To move the bit up. And so the 2D won't handle that kind of operation, right? Like that's not good for it, right? I'm looking, yeah. And then
Yeah.
the
It's
2.5,
going to burn, maybe like a laser or something is a good example of that, right? It can burn some tones in it or something, a half tone or dither, but really it's not going to do any kind of, texture that's raised and lowered.
Yeah. So this is interesting to me. The software pieces, when you get into what kind of software, Led was talking about using SolidWorks, right, which is a very industrial, full grade stuff. Some people use vCarve as their tool of choice. But the different softwares, we have to talk CAM versus CAD. So Led wants to do the CAD work or the computer aided design and come up with his 3D model. And then he wants to hand the 3D model off to somebody else that's going to do the computer assisted machining, I think it's called.
Mhm.
Right. And this is
Right.
where it actually builds the underlying technology is this stuff called G code. And so the CAM software is going to produce the tool paths. How far do you want to move? How many inches? What's the step downs? There's step rates, the step down rates. How much chunk do you want to take? If I need to drill something that's 2 inches deep, how far should I drill before letting up and getting off some heat and then drilling again? Right. So like drill operations are a thing. If I want to do a pattern that's got to go 2 inches deep, how much of each pass and how many passes do I want to take? Stephen would refer to these as feeds and speeds,
Yeah.
right? And they're a
You
huge.
gotta let the machine decide all that, you
Well, that's
know?
what the CAM software does.
So
Well,
The
what if
that's
you give it
why,
bubble gum, or what if you give it foam, or what if you give it, oak, or
uh-huh.
what if you give it IPE, right? These are, the machine doesn't know.
Yeah.
It's silly.
But we're not that far off though from an AI and artificial intelligence being able to operate SolidWorks, right?
Yeah.
Like that's something that really hasn't happened yet is hooking up AI to the actual CAD system.
There
But
are a few,
people are messing with it. People are messing with it. It's not,
yeah,
I would not call it a production technology yet.
no.
But we're not that far from an AI saying, hey, I'd like to build a robot version of myself and being able to do that using CAD CAM
Well, our kids will
processes.
think that's just everyday. People do that every day, right?
Right, right. And in terms of removing drudgery from humans, right, it would be us writing the music rather than having to play the piano, right? Like that's the analogy that people use. But I don't think we're 1,000 miles away from having an AI being able to operate simple things like SketchUp, like SolidWorks, and
So
that's going to be a big change.
I've been reading a book that I like very much. I've probably talked to both of you about it already, called Range. I'm really enjoying this whole idea of being a generalist versus a specialist. And one of the things they talked about in that book that just has stuck with me and has resonated over the last couple of months, when you talk to jazz musicians about playing jazz, and you ask one of them, "Can you read music?" A very common line in that business is to say, "Yes, but not enough to interfere with my playing." Right. And so, but if you're saying I'm going to write the music by putting down the notes, that's a very different thing than having my hands on the keys and knowing what I think sounds good. Right.
Uh-huh.
Do I need to be able to read music in order to play the piano?
You have the essence of what I'm talking about here. And
Yeah.
can an artificially intelligent machine ever do something truly new? Right?
Well, so can it actually produce?
Yeah, well, can it produce something new, right? Can it
Yeah.
can it draw a SolidWorks
Define
part
new.
that it has seen before? But it's going to be that is going to be an interesting evolution in this space because
So
it would be nice to just say, "Hey, cut me a picture of an American flag," and then it says, "Oh, do you want it to be 3D or 2D? Oh, how about 3D? Well, how big you want it to be? How about 3 feet by 6 feet? Okay," and then it like makes one.
yeah.
Right. Well,
It,
so I mean, I think the analogy is, uh, and that's obviously a complicated task, what you just described. The analogy might be writing a web page or some of the art rendering they're doing with illustrations and image creation today, right?
Sure.
And it's just, if you see the trend is going to get into the CAD space, and it's going to cut a boatload of time out of the CAD space. I mean, because
I think so too.
and it's going to give access to a lot of people that didn't have access. Because it, like at MySpace, we probably have 800 makers that are members, right? Of that 800, maybe 20 are proficient in CAD, right? Uh,
That's
and
exactly,
and
now you got exactly what I'm talking about.
and it's
And,
going to
and if you
be
can't draw a picture of a screw in SolidWorks, then you have a trouble moving forward in that craft.
Right, right. And CNC, like Matt's talking about.
Yeah. Yeah.
And
But that's quite complicated. It's quite complicated to do that task.
oh yeah, what kind of screw, what kind of threads you using, what pitch, what you know.
Yes.
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 Yep. Is it a 4x20 screw? Right? Like how many
Right.
threads you're going to have per inch? Kind of. Let me back up to the AI thing just for a second because that's not the episode. But the AI thing that I think is interesting is Chat
Squirrel.
GPT. Chat GPT will not draw you a picture, right? Right? Like you can't make Chat GPT draw you a picture because it doesn't produce them. But you can ask Chat GPT, please write me a JavaScript to run on an HTML page that will draw a picture of a turtle on the web page. And it knows how to write the JavaScript to draw a picture of a turtle. It just won't produce you the image file, but it'll produce a web page that has a turtle drawn on it.
Yeah, yeah.
Right.
Kind of meta.
And I
Kinda
think
meta.
that's so the tool helping the tool,
Fascinating.
right? The tool helping the tool. And again, if everything I'm passing to my CNC machine is just G code, there's no reason to think that the AI can't produce the G code, right?
Oh,
Like,
there is AI that will produce cheat code today.
right.
Yeah.
That's kind of slick.
But
And there's regular software called CAM that'll take your 3D thing and do all the tool pathing with you, right? But
Yeah.
you're in charge of setting a bunch of the parameters and stuff. It's very, very slick. So anyway,
Yeah. And
there's a
now Sarah Connor can sleep well knowing that the robots have got it. They're on the job.
exactly.
Isaac
Exactly. And they're not
Asimov.
taking away anybody's job.
No, they're not going to take away anybody's job except for, well, a few people, but not a lot of people. Okay, a lot of
It'll open
people,
up new
but
jobs. It'll open up
they'll
new
get a new
jobs.
job. Yeah.
Okay, so this is not a new topic. I want to make sure that I reference back to my science fiction origins that my older brothers convinced me to pay attention to. There was a gentleman by the name of Isaac Asimov who wrote about the Robot Foundation series and the rules that we had to have in place for how robots would operate.
Mhm.
Right. And the more recent generation would reference, I think it was Will Smith was in I, Robot, which was
Yep.
a very nice ripoff of that Foundation series. Um, and so what I will say is the idea that machines are taking over, 120 years ago, there was a big panic in the country that agricultural jobs were disappearing as farming technology advanced rapidly with the combines and the tractors and the right. If you had an automatic picking machine, then what was going to happen to all the agricultural workers?
Mhm.
And so this is not a new conversation, right?
No, not at all.
Technology is going to surpass us is a age old conversation.
No, I bet, and
You
like
and I-
Steven said, there's a lot of drudgery and a lot of lost design potential because of people being unable to efficiently operate CAD software. So that'd be really neat if we can let people into the space who can't get there now.
So here's what we're
Buggy
going to do.
whips.
I think
I'm
that
gonna go make buggy whips.
Steven's got something.
Steven
What?
We're
hit
gonna
us.
make buggy whips. No, that's gone. We don't have
Yeah.
buggies anymore.
Yes. Right. I'm going to be the guy who puts the wheels on the tire on the outside of the wheels. Right. That used to be a thing. And I was joking with
pooper.
friend. Yeah. Right. I was joking with friends at dinner tonight. Trish and I just bought a new vehicle, and our new vehicle came without an interesting feature that I was just expected to be there. So like I made this major purchase of a vehicle, and I forgot to ask whether it had a feature, and it did not. What do you think did not come with my new Honda Hybrid? What's the missing part on my car?
Steering wheel.
No, it has one
Key.
of those.
The key.
No, so it has a fob, and inside the fob is a backup key that you can put in.
Hmm.
What else is missing? What else would you expect a car to have? When you buy a car, what should it have?
Spare tire.
It does not have a spare tire.
Mm-hmm. Run
Inst-
flats.
It can't. No, it's not run. So it literally came where the spare tire is where the hybrid engine is,
Uh-huh.
right? So that's gone. So tucked away in one of the little side panels of the trunk space is a can of Fix-A-Flat.
Oh, yeah, there's your spare.
Nice.
Um,
Nice.
And then Trish and I were talking about it. When was the last time you had to change a tire? So we're going to end tonight's episode with a personal quiz. When was the last time you had to change a tire out in the wild?
I want a robot that does that.
No, that would be
years
a
ago.
cobot.
5 years. 5 years ago.
And Steven's very into cars. So Steven's saying 5 years. Like you're around a lot of go-karts. You're helping Mac with his
Mhm.
autocross, whatever it is, right? Auto rally.
Yeah.
right? Led's taken apart the front bumper of his Subaru in order to put on the headlights. Led, when's the last time you had to change a tire?
Yeah, I did take off the whole front cowling of my Subaru to get access to, because you can't get at the actual headlights without taking off the whole cowling, which was pretty annoying. So as to changing my own tires, I do my brakes. And so when I do my brakes, I have to remove the tires, but that's not the same as changing the
That's not
tire.
his question. That's
Um,
not his question.
I
Yeah,
want to
yeah.
say, quite honestly, the last time I had to change a tire, I couldn't get the spare to lower because the metal thing, because it was like dangling from the bottom of the bed. And I think it was a Sub 99 Subaru. And, I put the thing in there and tried to lower it, but of course it was all frozen shut, rusted. And I think I had to actually get a bolt cutter to get at the spare. I had to cut off the hanger system to get at it.
And how long ago was this?
Jeez, at least 10 years.
Right. So after thinking about it a little bit, I'm not as upset as I thought I would be that there is no spare tire, because I helped a young woman change a tire probably 25 years ago when Trish and I were living in Bloomington Normal. Right. But it's like I haven't had my hands on a tire wrench out in the wild for many, many years.
Wait,
So
wait, is that helped or helped air quotes?
no, I did actually help. I was at right. So the gender roles are a real thing in our society, and her and her mom were driving and didn't know what to do. So I showed up, and this is how you break the lug nuts.
All right.
Yeah, yeah.
All
So
right.
Good on
anyway,
you.
this has been fabulous. I'm going to call this the first, maybe episode 8, or my next episode will be more on CNC because we only very cursorily brushed the topic. I think like we got to the first 2 things on my outline of 15. So maybe my next episode will focus on CNC part 2, and we'll talk about some more interesting things. But hopefully somebody gets something out of this episode. I think I'm going to call it, unless we'll go around the horn. I like to go around the horn in the meeting kind of thing, and check in anything you want to contribute before we call it an episode.
I'll just say hooray for the rise of the robots. I'm getting older. I need robots to help me. So I'm into it.
I will reference the movie Wall-E. Just sit in your Barco lounger with the joystick and fly around is not the way to go, brother.
I'm in. I'm in.
I was watching social media today. I saw the West Point has these big projects they're putting out, and I see them because LED is on a bunch of that stuff. And they had EOD guy, right? That's an explosive ordnance guy, and he had the big bulky suit and the helmet, like I think a 7 or 8 pound helmet.
Yeah.
That's protecting his noggin. And they had a tether system. So this is like the fellows coming up with new ideas and stuff. A tether system to unload the weight from the helmet on the head of the EOD guy. So that was
So he's
kind
not
of
hurting his neck with all the weight of the
and
helmet.
he showed he could move all around, and he had like a little globe hanger thing on the top, all like that. So I think they have like 450 projects like that
We do.
every year.
We do.
Something like that, which is kind of cool. What's the other thing I'm doing? And then maybe we can, find out what Matt's doing. But I'm looking at ant weight battle bots, or I'm sorry, combat robots. Battle bots is trademarked.
Yes.
But the concept is you build a battle bot, right? That's under 1 pound,
Woo.
right? And
Under
you go
one.
destroy the enemy battle bot with yours, and there's no real robot part of it. It's really an RC car with armor.
Oh, you're driving it. You're driving it.
Yeah, right.
What's it
So-
made out of? Like a balsa wood?
The guys, carbon fiber. They'll use carbon fiber parts. They'll use PLA parts. They'll use TPU. Interestingly enough, TPU is like a rubbery printable substance, right? And they'll use that because it absorbs impact really well. So they'll put it on their front bumper if they're like a wedge thing. And then also you were using titanium, like for little special armored plating in certain areas. They'll use
Very little. If it's under a pound, yeah.
yeah, right. Like 20 gauge or something.
Wow.
something.
Wow.
I would think that some form of airbag system would be an interesting model, right? Like, so to give you that cushion so you can't get airbags might be we do a
Yeah,
thing in the
reactive armor, so
Right.
like
Yeah.
you hit it and it explodes back at you.
Right.
Wow.
it,
Hey,
in our computer science department, we actually run a contest every year where we have you're not allowed to remote control it. It has to actually be robot controlled, and we do sumo wrestling. So push the other robots out of the ring, right? And you have a downward facing camera that sees black, and then the ring is outlined in white. And when it sees white, it stops, so it doesn't run over the edge of the platform by itself. So you just drive in the area, and you decide how fast to turn, and you write this kind of stuff. So I read that was the solution. So last year, I helped a team on campus by adding a piece of white paper as a ring around their robot. So whenever everybody was trying to drive at the robot and push them off, it would see the white from their camera, right? And it would stop because it thought it was driving off the edge. And
no.
so nobody could smash their robot, and they ended up winning,
Right.
right?
That's a
Um,
Kobayashi Maru right there.
Yeah.
Correct. Yes. And then the
Is
computer
it-
science guy was like, "Hey, maybe don't do that." Right? Like so we modified the rules, and you're no longer allowed to have a ring of white paper around you.
You can no longer use Matthew the big cheater.
I thought this was spectacular.
That's
So
gaming the system. That's gaming the system.
Yeah.
Greg.
Well, we're running up on 40, 47, 48 minutes here. This is a long podcast. So
Led's an
thank
old
you to
man
all
and
our
he needs to go to
listeners.
bed.
Thank you to all our listeners who stuck around and tolerated our bloviating.
Oh no, Steven's going to chop it all up. I think this is going to be like a 14-minute episode.
Oh, is that
Oh,
right, Stephen?
I sure. Yeah. Mhm,
Good luck.
mhm.
Good luck with that. Good luck with that.
Brothers, you guys are awesome. Let's go ahead and give Steven his 3, 2, 1.